Determine the equation of the ellipse using the information below. The endpoints of the major axis are 5, 5 and 5, -3. The foci are 5, 4 and 5, -2. Let's go ahead and plot these points. The endpoints of the major axis are 5, 5 and 5, -3. This indicates that we have a vertical major axis, and the foci are 5, 4 and 5, -2. Because we have a vertical major axis, we use the form of the equation here on the right, where a is greater than b, and the equation is the square of x minus h divided by b squared, plus the square of y minus k divided by a squared equals 1. Notice the larger denominator is under the y part of the equation because we have a vertical major axis. The center is h comma k, the length of the major axis is 2a, the length of the minor axis is 2b, and a squared equals b squared plus c squared, where a is the distance from the center to either endpoint of the major axis, b is the distance from the center to either endpoint of the minor axis, and c is the distance from the center to either focus. Going back to the given information, let's determine the center. The center will be the midpoint of the major axis as well as the midpoint of the minor axis. Because the major axis is 8 units long, 8 divided by 2 is 4, we can determine the center by starting at either endpoint and moving inward 4 units. Starting at the top, moving down 1, 2, 3, 4 units, we have the center. Notice the center is the point 5, 1. Let's go ahead and record this. We need it for the equation. This indicates h equals 5 and k equals 1. The distance from the center to either endpoint of the major axis is equal to a. Notice here we have a equals 4. The distance from the center to either focus is c. Notice here we have c equals 3. We need to determine b to write the equation, or more specifically b squared, which we can do again using the equation a squared equals b squared plus c squared. Solving for b squared, notice we have b squared equals a squared minus c squared. Let's use this form of the equation. Again, we don't really need to find b, we only need to find b squared, but we'll find b so we can make a rough sketch of the ellipse. B squared is equal to 4 squared minus 3 squared, which is 16 minus 9, which equals 7. We have b squared equals 7, which is what we need for our equation, but this also indicates b equals the square root of 7, which is approximately 2.65. So if we want to make a rough sketch of the ellipse, we can find the endpoints of the minor axis by starting at the center and moving left and right approximately 2.65 units, or exactly square root 7 units. Starting at the center and moving right approximately 2.65 units, this would be one endpoint of the minor axis. Going back to the center and moving left approximately 2.65 units, let's say here, this would be the other endpoint. So this would be the minor axis, and now we can make a rough sketch of the ellipse. The ellipse would look something like this. And now let's write the equation of the ellipse. To begin, we have the square of x minus h, which is the square of x minus 5, divided by b squared, and b squared equals 7, plus the square of y minus k, which is the square of y minus 1, divided by a squared, where a equals 4, and therefore a squared equals 16 equals 1. This is the equation for the given ellipse. In the next example, we'll take a look at an ellipse that has a horizontal major axis. I hope you found this helpful.